Hello everyone, this is Umair Hassan and this is D4 and this is question number 6. We have solved previous question in the previous video. Question number 6 is D4 and exercise is 9a. Express 792 as product of its prime factors. Well, you can do that to 3 times 6 to 9 times 18 to 6 times 12 to 1 times 2 to 9 times 18 to 8 times 16 to 9 times 18 to 9 times 18, then 3 times 9, 3 times 9, 11 times 33 and 11 1 times 11. So 792 as a product of its prime factors will be 2 into 2 into 2 into 3 into 3 into 11, and in index notation it is 2 cube into 3 square into 11. Well, this one is your answer. This one, 2 cube into 3 square into 11. In part number B, they say that a number P has exactly 12 factors. Okay, there is a number P. In part B, there is a number P and it has exactly 12 factors. Okay, so we have been given two of the factors of P. Well, two factors of P are 4 and 15. Find the value of P. P has 12 factors. Two factors are 4 and 15. Well, you have been given two factors 4 and 15. Now we will take out the rest of the factors. Then 1 is a factor, obviously, because 4 is a factor of that number, 15 is a factor, then obviously 1 will be a factor. 2 will also be a factor of that number because 4 is a factor of that. 4 is a factor. 3 is a factor of that number because 15 is a factor of that number, and 3 is a factor of 15. 5 is a factor of that number P because 15 has a factor 5. Then you have 15, and then we have 6 factors. Rest of the factors will be obtained from these factors. 5 into 2, 10 will be a factor of that number. 5 into 4, 20 will be a factor of that number. Then 5 into 3, 15 is already there. 3 into 2, 6 will be a factor of that number. 3 into 4, 12 will be a factor of that number. 3 into 15, okay, 15 into 4, 60, that is a factor of that number. Then 15 into 2, 30 will be a factor of that number. How many factors do we have? 1 2 3 4 5 6 7 8 9 10 11 12. So these factors, all of these factors are factor of 30. So your required number P is basically 60, which have all these factors, 12 in number. Then we have question number 7. Express 525 as product of its prime factors. 525 as product of prime factors starting from 2. Well, 2 cannot divide any one of them. The 525 is not divisible by 2 3. 5 plus 2 7 plus 5 12. Yes, 3 can divide that because addition of these 3 is 12 and 12 is divisible by 3. So 3 1 times 3, 22. 7 times 21, 5 times 15. No, it will be divided by 5. 3 times 15, 5 5 times 25, 5 7 times 35, 7 1 times 7. So the factors of 525, the prime factors in index notation is 3 into 5 square into 7. 3 into 5 square into 7. This is the answer for part number A. Well, part number B says If LCM of 15, x and 35 is 525, find two possible values of x between 15 and 100. So we have been told that LCM of 15, x and 35, the LCM is 525, right? So what we can do here is that factorize 15, 3 5 times 15 and 5 1 times 5, factorize 35, 5 7 times 35, 7 1 times 7. Now the procedure of LCM is that write 15 as a product of its factors, 3 into 5, write 35, that will be 5 into 7. Observe that 5 is written under 5. We don't have a 3 here in the factors of 35, so it is left blank. We don't have 7 here in the factors of 15, so it is blank. So you can write here 3 raised to the power 0 and here 7 raised to the power 0 just to complete the columns. The next number is x, whose value is not known, and their LCM is 525, and 525 is basically 3 into 5 square into 7. This is what 525 is. Now this indicates that from this column you have taken 3 raised to the power 1 here. This is 3 raised to the power 1, which means in this column the maximum value of 3 is 3 raised to the power 1. So you can have two values of x here. Either here 3 raised to the power 1 is a factor of x. So let's write 3 raised to the power 1 here. We can also enter 3 raised to the power 0, because in both the cases 3 power 1 will be taken out, as the process is 5 square. Now this means that from column of this 5 you have taken out 5 square. Well, this is 5 power 1, this is 5 power 1, then this must be 5 power 2, because from each column you are taking out maximum power. So these are 5 power 1, so this must be 5 power 2, because this is 5 power 2. From here we have taken 5 power 2, then this must be 5 power 2, and this is 7 power 1, so this is 7 power 0, 7 power 1. It may be 7 power 1 or it may be 7 power 0, because this result won't be affected in either case. This may be 3 power 1 or this may be 3 power 0, but this must be 5 power 2 in order to have here 5 power 2. Now what are the possible values of x? If x is 3 power 0, if it is 3 power 0 into 5 power 2 into 7 power 0, then what? Then your answer will be 25, because 7 power 0 is 1, 3 power 0 is 1. But if x is 3 power 1 into 5 power 2 into 7 power 1, then 3 into 25 into 7, well, that is 25, 3 times 75 into 7. Well, this is a number which is greater than 100, but in question they have asked you to find value of x between 15 and 100. Well, that value of x between 15 and 100 is this one, 25. This is your answer. And we can have one more value here. No, let's suppose 7 power, here you have got this power 7 power 0 here in the factors of x, 7 power 0. If 7 power 0 is here, then 5 square into 3 power 1. If x has factor 3, if x has factor 5 square, if x has factor 7 raised to the power 0, which is 1, then 5 square into 3, 25 into 3, x is 75. So this is the second answer for this one between less than 100 and more than 15, and this is your first answer for this value of x. In part number C of this question number 7, If 525k is a perfect square, find the smallest possible integer value of k. Okay, so the problem here is that no, 525 is a perfect square. This 525, this is a perfect square, and if this is a perfect square, sorry, 525k is a perfect square, part number C, question number 7. Now 525 is 3 into 5 square into 7, and here you have k. Now what must be the value of k in order to complete a square over here and over here? If we have 1 3 more here, mean if k is 3, 3 into 3 is 3 square, 5 is already in square form, and if k is 7 as well, mean k is 21, 7 into 3. 3 into 3 becomes 3 square, 5 is already a square number, 7 into 7 is 7 square. So I need 3 and 7 to make these numbers in square form. So k must be 3 into 7, that is 21. Then all these numbers are in square form, and they will be a perfect square. So k will be equal to 21. The answer for this part number C. So this is the solution of the question number 6 and 7 from D for 7th edition, chapter number 9. Keep watching. Thank you so much.